guys, a very good afternoon to all of you. So friends, we are going to continue in our journey of learning permutation and combination. We have already taken the first session a few days back. Frankly, this is not going to be a learning journey per se, as I already mentioned. The assumption behind these sessions is that you have some basic idea about the topic already. So I'm not taking you through the very basics that way. Yes, I'm trying to give you as many basics as possible whenever required, but this is not a theory class. This is not a class for people who are starting off PNC right now and they want to learn everything. That is not the intention of the class. So having said that, let's continue in our journey. In the last session, we have seen the difference between permutation and combination. What exactly is a permutation, what exactly is a combination, and then we went ahead and we have seen certain questions using the concepts of permutation. Today we are going to continue with 3 or 4 problems of permutation because I could not complete these. These are important models. I could not complete this in the previous session. So I'm going to continue with this today, and then we are going to start solving questions on combination. Right? So that's what we have in store today. So the first thing we're going to do is continue with the questions from the previous session. There are 4 questions that were pending. I'm going to start with the 4 questions pending over here. So you can see the first question. Take about 45-50 seconds or 1 minute, and let's see if you can come up with an answer to this particular question. Find the total number of ways in which 15 distinct bottles can be distributed among 3 boys. So here distinct word is used for bottles, but the word distinct is not required for boys. Understand guys, in any question, when you're dealing with living things, especially people, animals, you will consider them as distinct. You will consider them as distinct. Please keep that in mind. So they don't have to mention that. Such that each of them receives the same number of bottles. So here, you are looking at 3 boys, boy 1, 2 and 3. They are distinct. So first boy, second boy, third boy. I can call them as first, second, third. So each one should get 5 bottles accordingly. Each one should get 5 bottles. So the way in which you can distribute 15 as 5 such that each boy gets exactly 5 and all 3 boys are distinct is given by the formula. In fact, it's basically a derivation of it's derived from the concept of combination. So basically what you're saying, if you understood the basics of combination that we discussed in the previous session, you are first picking 5. Out of 15, you're picking 5 and give it to the first person. The first person gets 5, correct? So how many ways can you pick 5 out of 15? It is 15C5. And remember, it is the fundamental rule of multiplication. You want to fill all 3 slots. So, and. Now, we are moving to the second boy. Second boy, how many bottles are left out for him? 5 are already gone. So, there are 10. You again have to pick 5. 10C5. Automatically, the remaining 5 will go to the last student, which is 5C5, which is 1. This basically can be converted into a formula, which will turn out to be this. Okay, which will be turning out to be this. So this is basically 15 factorial by 15 minus 5, which is 10 factorial into 5 factorial, and 10C5 is 10 factorial by 10 minus 5, 5 factorial into 5 factorial into 1. So this 10 and 10 gets cancelled, and therefore you'll be getting the answer as 15 factorial by 5 factorial whole cube. Okay, 15 factorial by 5 factorial whole cube. So this is the, you can also remember this as n factorial by r factorial whole cube, where n is the total number of distinct items and r are the number of items that each person is supposed to get. 2 assumptions here. First assumption is all these items are distinct and the number of groups are also distinct. So this concept is applicable only when the items are distinct and the groups are also distinct. You can differentiate between the 3 groups or 4 groups or 5 groups. So that is how you get. Now what is R? Remember, R is not the number of groups. R is the number of items going to each group. R is the number of items going into each group. Clear? Now a slight modification of this question is the second one we have. Here is this slight modified question here. Take a look at this and see if you can get the correct answer to this. So total number of ways in which once again 15 distinct bottles can be distributed among now similar boxes. So boxes when they mention it's a non-living thing. So when there are non-living things given to you, you can have two cases. You can talk about distinct boxes or similar boxes, identical boxes. So here is the case of identical boxes, because if it is distinct boxes, it is back to previous question. There's no difference. Whether it's a box or a person, you can identify the difference. They are the same for our concept. But here, the difference is you're dealing with similar or identical boxes. So the formula will be very similar. The concept will be very similar, provided the only difference is, I'll explain the logic why there will be a difference between this and that. Let me take a simpler example for you to understand this. Let us say I want A, B, C, 3 letters, and they are placed in three people who are made to sit in 3 places. Okay, how many ways can you make them sit? You can make them sit as ABC, ACB, BCA, BAC, CAB, CBA. 6 ways totally. Now, same question. Let me ask you, if there are 2 letters A and B, or A and C, then how many ways can you make them sit? Now, the problem here is, if you go by the same logic, the difference between here and here is 2 A's are looking exactly the same. So compare this B with this A. So ideally it should have been A, B, C and A, C, B. 2 different things. But because this B is A and this B is A, now when you look at AAC, these are 2 different things. But now also look at the question of BAC. This becomes AAC. These 2 are going to be the same. So you will not count it again. So if you go by this funda or this formula, that is basically all of them are distinct, you will notice that you'll get more number of cases. But when some things are identical, you will get a lesser number of cases than what you need. Okay, you'll get a lesser number of cases than what you need, because when A and B interchange, here you'll get separate cases. But here when A and A interchange, there is no case. So if you remember, we already discussed this. If I want to find out the number of ways in which A, B, C is supposed to be arranged, it is 4 factorial by 2 factorial. We already saw this. This 2 factorial comes for number of things which are identical. Similar concept comes in this case also. So the answer will be 15 factorial by 5 factorial whole cube, like in the previous case. But this is the case, this is the answer when everything is distinct. But when you have 3 similar boxes, you will have to divide this by a 3 factorial. You have to divide this by a 3 factorial, therefore the answer becomes C. Why are we dividing it? As I already explained, the number of cases will not be this much. It will not be this high. It will be a fraction of this, and the fraction is basically division by 3 factorial. Okay, so this is the case where you're distributing distinct things into similar looking boxes or similar looking places. Clear? That is your basic answer. Option C. Next question is one more thing that we got left out last time. A and B are a part of a group of 8 students. In how many ways can these 8 students sit around a circular table such that A and B are always together? Now we already saw the concept of circular arrangements. Circular arrangements. So we know that if n people are to be made to sit in a circle, they can be made to sit in n minus 1 factorial ways in a circle. We already discussed the theory why it is like that. It is an application here with a small twist. What is the twist? A and B should always be together. Now, when 2 people are supposed to be sitting together always, then the logic is you will combine them into a person called X. And you will say this is one person now, not 2 people. So let's take a simpler example for straight line. Straight line is easy for you to understand. So let us say 8 people are sitting in a straight line. Okay, 1, 2, 3, 4, 5, 6, 7, 8. Now instead of saying 8 people, I will say there are only 7 people, because I'm combining A and B into one person called X, and the remaining 6 people are there. So totally I have 7 people now. Now this X, wherever I make it sit, will always be together. A and B will always be together because it's a part of X now. So now I will say they will sit in 7 factorial ways in 7 places. 7 factorial ways in 7 places. But wherever they are sitting, in this X, inside this X, A and B can interchange. A and B can interchange. So 7 factorial arrangements where X is a part of the arrangement, but within X, your A and B can interchange. So into 2 factorial. This is the concept we are going to use. So always together. We saw what happens when none together, right? Well, last time we have seen that. So this time the whole concept is they are supposed to be together. So always together concept is you combine them and call it as one entity. All of them, how many ever they are, one entity. Solve the problem taking this new number of people, reduce number of people and get an answer. Then multiply it with the 2 factorial, 3 factorial or 4 factorial depending upon how many people have been combined. So one way of looking at this is if there are in a straight line, I'm giving you a formula for a straight line. In a straight line, n people to be seated, out of which r people should be always together. So you can remember it like this: if out of n people sitting in a straight line, if r people have to be always sitting together, then straightforward the answer will be n minus r plus 1 whole factorial into r factorial. This is your answer. But this is only for a straight line. Now what happens in a circle? The concept remains the same. In a circle, the concept also remains the same. So if there are 8 people in a circle, first let me form from 8 people, I will join this A and B into one group and I'll create a new problem where there are 7 people. Who are the 7 people? X and other 6 people. X and other 6 people. That's total 7 people. Now my problem becomes 7 people are sitting in a circle. How can they sit? Now we know if 7 people are sitting in a circle, this can be made to sit in 6 factorial ways. 6 factorial ways. Now once you got the answer, go and take a look at what is happening inside X. X, there are 2 people. They can interchange. So this answer should be multiplied by 2 factorial. So the correct answer is option D. 6 factorial into 2 factorial. Size 3 is asking CMAT expected date. Size 3, I don't think CMAT will be happening this weekend anyway. So frankly, I'm lost too. It could happen anywhere from the end of this month to it can go to the next month also. Typically, they will not give you 5 days time and say, okay, CMAT is happening. So this month, this week is gone. So the only difference, only thing you can expect is if the notification comes out in the next 1 or 2 by Wednesday, then you can expect the exam can happen on the next weekend, not the coming one, the one after this. But if the notification is not out by Wednesday also, I would say next weekend also is gone. So the weekend after that could be a probability. That's the only thing. Okay. All right. Moving on to the next question. Similar question now. In a circular arrangement, A and B are part of a group. In how many ways can these 8 students sit in a circle such that A and B are never sitting together? Now this can be done in 2 ways. The concept of never together, which we already saw. Here we can do it in a smarter way also. What is the smarter way? Total 8 people, how many ways can they sit? 8 people in a circle can be sitting in 7 factorial ways. From this, subtract the ways where A and B are always together. We already calculated. That is 6 factorial into 2 factorial. That's it. That's your answer. So you can do this using the funda of never together. You can also do this using total minus what we don't want. Okay, what we don't want is easier because we already calculated in the previous question. Otherwise, you can also do it as, okay, make the other people sit first. In the gaps, make these 2 people sit, your job is done. Either way, you will get the same answer. So the correct answer will be option B, 3600. If you subtract this, basically if you take out 6 factorial common, this will be 6 minus 2, which is 4. So this is 720 into 4. So 0, 8, 7, 4s are 28. Oh, sorry, I made a mistake. 6 factorial if I take out common, 7 minus 2. 7 minus 2 is 5. So 720 into 5. 5, 0, 5 2s are 10, 1, 7 2s are 35, 36. So 3600 should be your answer. Okay. Now, guys, we are going to move on to the topic for this session, starting with basics of combination. We already seen that. Applications of combination is what we're going to look at. So there are 4 or 5 applications we're going to slowly take today and see questions based on that. The first question is number of diagonals in a n-sided regular polygon. Whether it's a regular or not doesn't matter, n-sided polygon. Now the formula for this is basically nc2 minus n. Now the logic is very, very simple. If it is n-sided, regular or not doesn't matter. It doesn't have to be regular for any polygon, any convex polygon, n-sided. Then you basically have n vertices or n points. So the funda is very simple. Any 2 points you take, you will get a line. Any 2 points you take, you will get a line. So number of lines are nc2. But not all lines are diagonals. Why? Because there will be some sides also. So subtract the number of sides. So number of lines is nc2 minus the number of sides. The remaining every line is called as a diagonal, because the lines are either diagonals or sides. When you take 2 points, any 2 points from this figure, they will either be forming a diagonal or they'll be forming a side. So nc2 is the total number of lines. From that, subtract the number of sides. That is the formula. You can also remember this. You can simplify this and remember it, or I never remember it as a formula, but the formula will be n into n minus 3 by 2 if I'm not mistaken. I could be wrong also because I don't remember the formula. You can basically try to simplify this and see. I always remember it the concept wise like this. Okay. Next, the number of straight lines that can be drawn from n non-collinear points. This we already saw. Non-collinear means no 3 points are in a straight line. So any 2 points you pick, it is a straight line. Any 2 points you pick, a new straight line is formed. So n points are there. How many ways can I pick 2 points? nc2. The same question can also be asked as, if there are n people and everybody shaking hands with every possible person, total how many ways, how many shake hands are going to take place? So it is any 2 people you pick, there will be 1 shake hand only. Any 2 people you pick, there will be 1 handshake. So nc2 total number of handshakes will be registered without repetitions, right? So A and B will have only 1 shake hand. A and C will have only 1 shake hand, handshake. A and D will have only 1 handshake, and so on and so forth. So that is given by nc2. Nothing more than this. Simple. Similar logic, number of triangles that can be formed by non-collinear points. Again, for you to form a triangle, you need 3 points that are non-collinear. If anyway the points are non-collinear, then from the points, any 3 you pick, it will form a triangle. Correct? So, how many triangles are going to be there? nc3. Very simple. Any 3 points you pick out of the n, you are going to get a triangle. Right? Finally, the 4th point. Number of triangles that can be formed from n points, out of which now we have a collinearity coming in. So if there are totally n points and there are some of them which are collinear, some of them which are non-collinear, then what happens? So firstly, what is the effect of collinearity in our triangles? Remember guys, if there are points in a straight line, you are not going to get any triangles here. So if you say 4C3 triangles you are supposed to get, you are not going to get them. Why? Because any 3 combination you take on these 4, it will give you the same straight line. You are not getting a triangle at all. Therefore, the total number of triangles will be, ideally it should be nc3, but you are losing some. What is it that you are losing? mc3. Because these m points will not give you even a single triangle. So how many triangles you are losing? mc3 number of triangles you are losing out. So nc3 minus mc3 is your answer. Similarly, it can be extended for 4, 5 and so on. But now the beauty is for 2 points, which is a straight line. Same question if I ask you, there are n points out of which m are collinear. How many straight lines are possible? Same, ideally you should have got nc2. What are you losing? mc2 straight lines you're losing, but here you'll get a +1. Why? Because notice here, you are not losing all the straight lines, you're getting 1 straight line in place of all of them. So when you're subtracting mc2, you're saying you're not getting anything, which is true for a triangle because no triangle you're getting. But in a straight line, all these straight lines you're supposed to get are not there, but in their place you're getting 1 single straight line. That is why you're just not subtracting, you're adding +1 also. So in a triangle, this +1 will not be added for the same reason. For a straight line, this +1 will be added. Clear? Let's take a look at simplification. 12c4, very straightforward answer. What is this? 12c4 is 12 factorial by 12 minus 4 whole factorial into 4 factorial. Now guys, instead of writing this, I will give you a faster way to remember this. 12C4, basically write 12 into 11 into 10 into 9. So write, this is 4, so write those many things in the numerator. Divide by straight away 4 factorial, 4 into 3 into 2 into 1. So you don't have to do this calculation, then cancel things, waste of your time. Basically this cancellation directly happens by just observing this. So you write 12 into 11 into 10. How many terms should you write? You write the number of terms that are here. And the remaining denominator will be 4 into 3 into 2. So 4 into 3 into 2, so 3 2s are 6, 6 2s are 12. Then 4 goes, so 2 goes 2 times, 2 goes 5 times. So 55 into 9. So 9 5s are 450, 9 5s are 45. So 495, which is option A. Now one small other trick also. Let's say you want to find 12C10. Now, are you going to write 10 terms, 12 into 10 and 11 into 10 into like this? Will you write 10 terms? Don't. What should you use? If you want to find out 12C10, we know NCR is equal to NCN minus R. So this 12C10 should be equal to 12C2. Always try to convert this into a smaller number. So NCR is equal to NCN minus R. Use that funda. So it is 12C2. Therefore, this becomes 12 into 11 by 2 over 66. That case, the answer is going to be 66. So if you have a big number here, convert it into a smaller number, then do the same logic we used. Okay. Next question. How many diagonals are there in a 11-sided polygon? We already saw the answer. NC2 minus N. So 11C2 minus 11. So 11C2 is 11 into 10 by 2 minus 11. 2 5s are 55 minus 11, 44. Very, very simple, straightforward question. It's a direct application, right? Moving on. Okay, now we have slightly different kind of a question. Take a look at it and try to see if you can get an answer. So what is happening here? Nikhil has 3 sons for whom he wants to purchase New Year gifts. He went to a shop where the shopkeeper showed him 10 different gifts. If Nikhil purchases exactly one gift for each of his son, in how many ways can he, remember, select the gifts? He is not saying he's giving one, he's buying a bunch of 3 gifts. He's not arranging which gift is going to wear. That's the only difference here. Be careful about the word select the gift. So basically you're selecting 3 gifts out of 10. Who is getting what doesn't matter for us. Right now in the shop we are best picking 3. After going home we'll decide who will get what. So 10C3 is your answer. So 10C3 is 10 into 9 into 8 by 3 into 2. 3 factorial is 3 into 2. 3 goes 3 times, 2 goes 4 times, so 120 is your answer. Option A. Once again, simple question, right? Here we have slightly different question once again. Similar starting but a small twist. If Nikhil purchased exactly one gift from each of his sons and has already rejected one of the gifts due to its price. So 10 gifts are there. One gift is too high in cost. So he's not going to purchase it. What is the number of ways of doing it? So basically you now have only 9. So basically it is 9C3. That's all. 9C3 is 9 into 8 into 7 by 3 into 2. So 2 goes 4 times, 3 goes 3 times, 12 into 7, which is 84. So there is hardly any difference between previous question and this question. Okay. Next, combining the basic idea that we saw last time, we are going to have a new type of a question here. What is the question here? From a group of 6 boys and 7 girls, a team of 5 members will be formed. In how many ways can the team be formed if there are 2 conditions? There should be a separate answer for this. There should be a separate answer for this. So let's see if you can get the answers differently for both of them. Okay. A team has exactly 2 boys. The team has exactly at least 3 girls. So at least 3 means 3 or more. Clear? Okay, let's start with the first question, the first part. 2 boys. First, I want a total of 5 people. 5 people. So 2 boys means 3 girls. Exactly 2 boys means exactly 3 girls. So out of 6 boys, I can select 2 in 6C2 and 7C3. 6C2 and 7C3. That is your answer. So 6C2 is what? 6 into 5 by 2. 7C3 is 7 into 6 into 5 by 3 into 2. This gets cancelled. 2 goes 3 times. So 15 into 35, or rather 25 5 is 25 into 21. So 25 into 21. So 25 20s are 500 plus another 25. So 525. This should be your answer. Correct? So how did I do that simple multiplication? I took 25 into 20 first. So 25 into 10 is 250, double of that 500 plus 1 is remaining. So 25 into 1 is 25. So 525 is your answer. The team has at least 3 girls. Now this is where the calculation becomes a little bit tricky. At least 3 girls means you can look at 2 boys, 3 girls, one possibility, or 4 girls, 1 boy, or 5 girls, 0 boys. 3 cases exist now, and it is either or. So or. So it is basically first answer plus second answer plus third answer. 2 boys and 3 girls we already saw, 525. Right? Next, 1 boy and 4 girls. 1 boy is 6C1, 6 ways, and 7C4. What is 7C4? It is 7C3. 7C3 is basically 7 into 6 into 5 by 3 into 2, which is 35. And all 5 are girls. If all 5 are girls, it is 7C5. 7C5 is 7C2. Right? 7C5 is 7C2, which is 7 into 6 by 2. 2 goes 3 times, 7 3s are 21. So your answer for the second case will be 525. 6 into 35, 6 3s are 180, 6 5s are 30. 180 plus 30 is 210 and 21. So 6, 2 to 4 plus 1, 5, 756. So second answer is 756. Okay? Clear? So this is how you solve your P and C questions, especially the combination questions. Take cases that you want. You can also do this in a second way. The second portion can also be done in second way. Total ways minus less than 3 girls. So what is the total number of ways? Total number of ways is you have 7 plus 6, 13 people. So 13C5. From this, I will subtract the cases where less than 3 girls are there. Less than 3 girls means 2 girls and 3 boys, 2 girls, plus 4 boys, 1 girl, plus 5 boys, 0 girls. All these you don't want. So the reason why I am giving you the second approach is in some questions, this is easier to solve. Here this is difficult to solve. But remember the approach. Total minus what you don't want is also a decent approach in P and C. Certain questions we end up solving this in this way, which is going to be faster than the direct approach of what you want. Sometimes what you want will turn out to be difficult. So you can remember this other approach also. Nishant says try to write in a proper manner. Okay, Nishant, I'll try to do that. Sorry. I was never a person to have good handwriting, so I'll try to write slowly and try to write better. Right, Nishant? Okay. In a badminton tournament, there are 66 games in which the players were girls and 180 games in which one of the players was a girl and the other was a boy. If each player played with the other player exactly once, then find the number of games in which both players were boys. So take a look at it, understand, apply the logic. I'll give you 1 minute to see if you can come up with an answer. Let's see how many of you will get the correct answer to this. Any answers, anyone? Let's take a look at it. There are 66 games in which both players were girls. So remember, if there are totally G number of girls, then number of games is like calculating number of handshakes. So GC2 should be equal to 180. Or G into G minus 1 by 2 should be equal to 180. Or G into G minus 1 should be equal to 360. So basically, you're getting a quadratic equation. But don't waste your time. Split this 360 into two numbers such that the product is 360 and they are consecutive. Think about it, which two consecutive numbers will give you 360? So the best way to look at that is look at the nearest square root of 360. So 20 20s are 400. So the answer should be somewhere around 1920 or 20, 20 20s are 400. So it should be 1920 or 1819. So 19 into 20 is how much? 9 2s are 8. It is 380. We don't need this. So go one step lower. 18 into 19. Is this possible? This is 66, right? 66 games. My bad. This is 66. 66. So this will be 132. Okay, if it is 132 again, what is the square root of 132? Very close by. 10 10s are 100, 11 11s are 121, 12 12s are 144. So 11 and higher, because 11 square is 121. So we need 132. So it should be more than that. So 11 into 12. So 11 into 12 is 11 11s are 121 plus another 11, 132, very clearly. So your G should be equal to 12. Because remember, it is 12 into G minus 1, 11. So the number of girls are 12. Similarly, now the number of boys. 180 games in which one of the players was a girl and the other was a boy. Okay, so now we are talking about one player is a boy, one player is a girl. So number of ways of choosing one girl is 12C1. Number of ways of choosing one boy is BC1. Let's say the number of boys are B. Why am I doing this? Because if I want a game between a girl and a boy, I will first pick one girl and then I'll pick one boy. That is going to give me a game. So how will you pick one girl? How many ways can I pick one girl? 12 girls, so 12C1 ways. How many ways can I pick one boy? We don't know the number of boys. Let's call it as B. So BC1 ways. So this product should be equal to 180. We already know this is 12. 12 into B should be equal to 180. Or the number of boys is 180 by 12. So 12 ones are 12, 6 is the remainder, 60. So 12 5s are 60. So the number of boys are 15. Now the question says, find the number of games in which both the players were boys. So you have both players as boys, B, C, 2. 15C2 is your answer, which is 15 into 14 by 2. 2 goes 7 times. So 7 10s are 70, 7 5s are 35. The total is 105. Option B. Clear? Let's move on. Okay, here we are going to learn a new concept called the sum of or the number of non-negative integral solutions and number of positive integral solutions. So this is a new concept we are going to learn. The concept says, if I say A plus B plus C plus, or rather let me put it this way, A1 plus A2 plus A3 plus up to AR. I am taking R number of terms. The total is equal to N. The total is equal to N. The number of ways of having these numbers adding up to N such that all of them AI belongs to either positive integers or AI belongs to whole numbers. Non-negative integral solution means 0 onwards. 0 can be a possible answer, possible number. Positive integral solution means positive integers. So for example, if I take A plus B equal to 5, so I can, and if I say A and B are positive integers, then my possible answers are 1, 4, 2, 3, 3, 2, 4, 1. That's it. If I say non-negative integers means 0 and 5, 1 and 4, 2 and 3, 3 and 2, 4 and 1, and 5 and 0. How do you count this? Is there a direct way of counting it, getting an answer without writing this down every time? Because for 5 I can write, for 500 I cannot write. Yes, thankfully there is a direct formula. The formula says for positive integral solutions, the formula is n minus 1 C r minus 1, where r are the number of digits, or rather number of numbers, and n is the total adding up to. This is the case of positive integral solutions, whole numbers. Natural numbers. Positive integral solutions are natural numbers. Then we have non-negative integers. Non-negative integers means 0 can be a possibility, so whole numbers. So if it is non-negative, then the formula becomes n plus r minus 1 c r minus 1. Then the formula becomes n plus r minus 1 c r minus 1. Clear? Now, if you're interested in the derivation of this formula, it's very, very interesting. So basically what they do for the derivation is, let me take a simpler case to explain. If I say a plus b plus c is equal to n, I will say let this n be actually 1 plus 1 plus 1 plus 1 and so on. Because I need, if the total is n, I need how many ones? N number of ones, correct? So let me write the ones. 1 plus 1 plus 1 plus 1 plus, like this I have n ones. Now the logic is very simple. I will put two bars. I'll explain what I mean by bars. Two restrictions to break this chain, this entire chain into three parts. So let me put one bar here, literally a line here, draw a line, and I'll put randomly one more line here. So I will get A, which is the total here. This is going to be called as B. This is going to be called as, the remaining is going to be called as C. So every place I put a bar, two bars. How many bars do I need? If I want three spaces, or if I want three, pieces, I need only two bars. I need to cut it in only two places, correct? So wherever I cut it, I'll get the leftmost, middle and the rightmost, correct? So the total number of places for me, how many places are there? Wherever there is a plus, I can put a bar. Wherever there is a plus, I can put a bar. So how many places are there? If there are n number of ones, the number of places will be n minus 1. Now I am choosing two places. If I am choosing two places, it is nc. In this case, it is 2. Now where did I get the 2 from? 2 comes to me because if there are three, I need only 2 cuts. If I want 4, I will need 3 cuts. So basically it is n minus 1 c. If there are r, I need 1 less cut. So n minus 1 c r minus 1. This is the way in which you get the answer for positive integral solutions. Now let's go ahead and take a look at the non-negative integral solutions. How will I get non-negative integral solutions? The same logic will extend it a little bit. So logic says once again a plus b plus c is equal to, let's say, n. Now the condition is a, b, c can be non-negative integral solutions. So then how do I get my answer? No problem. What I'll do is, while I know a, b, c can be zeros, I only know the formula of how to deal with positive. If a, b, c are positive, I can get my answer now, correct? If a, b, c are not positive, how do I convert this question into what I know? So what I'll do is, I will add plus 1, plus 1, plus 1 for each one of them. So if now remember, my equation should not change. So left side I'm adding plus 3. So right side also I'll add plus 3. So now a plus 1, I will call it as x. B plus 1 I'll call it as y. C plus 1 I'll call it as z. So x plus y plus z should be equal to n plus 3. Now tell me, what is the nature of x, y, z? A can be a 0, B can be a 0, C can be a 0, but x definitely cannot be 0. Minimum it will be 1. So a, b, c can belong to whole numbers, but x, y, z will belong to natural numbers. So we converted this problem into what we know. Now I can apply the formula. This is my new n. Let's call it as k. So my formula now becomes k minus 1 c r minus 1. But what is k? K is actually n plus 3. So basically k is n plus r minus 1 c r minus 1, because the 3 came because of 3 ones that I'm adding. Why did I add 3 ones? Because for each term it is plus 1. So if there are r number of terms, I'll add r ones. So it is n plus r minus 1 c r minus 1, and that's how you get the formula for non-negative integral solutions. So if you apply this, you will straight away get this answer here. This is 12 and this is 4. So this gives 11c3, and this gives 12 plus 4, that is 16 minus 1, 15c3. So 11c3 is 11 into 10 into 9 by 3 into 2, which is 6. So 3 goes 3 times, 2 goes 5 times, 15 into 11. 15c3 is 15 into 14 into 13 by 3 into 2. 2 goes 7 times, 3 goes 5 times. So this is 35 into 13. So 15 into 11 is 150 plus 15, 165. And 35 into 13 is 350 plus 35 into 3. 35 into 3 is how much? 90, 105. So 455. So the answers are 455 and 165. So first answer is 455. Second answer is 165. Okay. Last question for the day. Find the number of triangles that can be formed by 10 points, out of which exactly 3 points are collinear. Direct application, we already know the answer to this. If there are n points, out of which m are collinear, the answer is nc3 minus mc3. So 10c3 minus 3c3. So 10c3 is 10 into 9 into 8 by 3 into 2 minus 1. 2 goes 4 times, 3 goes 3 times, 120 minus 1, which is 119. So guys, that brings us to the end of your basics of PNC. This is a basic class. We will have more sessions later on where we will take up higher level problems of permutation and combination. This is not the higher level problems. This is for students who understood the theory part and getting practice problems at the level 1, level 2 problems. Higher, moderate and above moderate problems, we will take up other sessions and we will go ahead and solve them later. Okay, so we have some good news from our side. We have some great students who got excellent scores this year from BYJU'S Exam Prep. So you can see that over here, Vinayak, Sarojit, in fact, some of them are my mentees, some of them are Mr. Gautam's mentees. So we have been able to train the students who got these scores to give interviews. So we are waiting for the interview results. Some interviews are already out, some results are already out. Some of our students got into SPJ and some of the students got into SIBM Pune. We have some good results. We are waiting for Ahmedabad, Bangalore, Calcutta, Indore, Lucknow and Kozhikode results too. FMS is conducting its interviews right now as we speak. So all this is yet to happen. So if you are going to be a part of our ecosystem, part of BYJU'S Exam Prep journey, we will make sure that we hold your hand till you get into the B school. Right? So guys, go ahead, download our app and try to be a part of our educational journey. Thank you and all the very best for CAT 2023.